Hello team, we're going to look at video number 2 of our how to use a multimeter series, and this one is going to be continuity and resistance testing. So firstly, what are those things? Well, we saw in the last video that resistance and continuity were two different functions on our multimeter. So why am I lumping them together? Well, they're essentially the same thing. We're just going to use them in slightly different ways. Let's have a quick look at our meter again. So we have here on our meter continuity function here, that's the beeper symbol, and our resistance function at the bottom, that's the ohm symbol, which could give us 200,000 or 200 depending on what I'm testing. Now they're both essentially the same thing. If I'm looking to measure the resistance of something, what I'm trying to do is measure that there is a circuit from one end to the other, and I want to know how many ohms that circuit is, whether it's a piece of wire or a resistor or whatever you like. That there is a circuit from one end to the other and how much resistance there is in it. When I'm looking to measure continuity, all I'm measuring there is there a circuit from one end to the other? This might be useful if I'm just testing a wire, for example. Is there a circuit from one end of this wire to the other? Particularly useful if I can't see that wire, if it's in the wall or it's covered by insulation. I just want to know, is it continuous from one end to the other? I'm not particularly interested in the resistance. It shouldn't be a high resistance, it should be very low. I just want to know, is it continuous from one end to the other? That's a really helpful thing when I'm doing fault finding. So I don't need to see on my meter the physical reading. I'm not really too worried about that. I just want to know that it's continuous from one end to the other. So really that means our continuity and our resistance testing are more or less the same thing. It's just that resistance testing, I want to get the actual resistance, and continuity, I'm just testing end to end. Okay, so let's actually do a demonstration on that and have a look at how we do each of those things. Because continuity or resistance is a property of a conductor, of a physical thing, we measure it by its effect, which means that my meter is going to put a small voltage onto the end of these probes. When I connect the probes to a circuit, a current will flow through from red through my load, or whatever I'm testing, back through the black, and a small current will flow. The meter will measure how much current is flowing, and using Ohm's law, resistance equals voltage divided by current, it will be able to display what the resistance of that circuit is. Before I do anything, I just want to prove my meter, and I'm going to use a technique we call prove, test, prove. If you want to know more about that, go to the video on voltage testing, where I'll discuss in detail prove, test, prove, and the safety requirements of using that technique when we're doing voltage testing in particular. But for my continuity or resistance testing, my prove here is I just want to know that my meter is working and that will read a circuit. So I'm just going to put it on the continuity. I'm going to touch the ends of the leads together. And you see that I get a beep, I get an audible beep, and a light. That tells me that there is a circuit. Current is flowing from the red lead, through the tip, across the touching tips, back through the black, and I've got a circuit flowing, and my meter is going to give me that beep. Okay, so that's my prove. I've proven the meter is operating. I get a beep when I touch the leads together. Okay, so what can I test when I want to do continuity testing? Well, let's have a look at this switch here. So this switch has a number of wires soldered to it, but we're going to concentrate on the purple and the blue here, and I can see that they are wired to two terminals of the switch, the purple and the blue, and I can tell you that those two terminals will switch when the switch is moved. So if I take my multimeter leads and connect them onto the ends of these wires, I should be able to tell when the switch is closed. We can see that I've got the black lead on the purple wire and the red lead on the blue one. We should be able to tell when the switch is closed, because if there is a complete circuit from the red lead through the blue wire through the switch, returning through the purple wire through the black lead and back to my meter, when there is a complete circuit there, the meter will beep. And there we have it. That tells me, what have I just figured out here? When the switch is in this position, it must be turned on. When it's in this position, it's off. If I, for example, were to switch it both directions and get no result, then I could say this switch is faulty, or I'm connected to the wrong terminals. I might have to do a little bit more testing to figure out which is true, but I can do that all with continuity testing. And that's why continuity testing is useful. I'm not really concerned, as I said, whether the what the actual resistance of that circuit is. I just want to know that there is one present. And I could also do that just down the length of a wire. If I was not sure if this switch was working, if I tested it here at the switch contacts and everything seemed to be fine, then I would think, well, perhaps my my fault is in the wire itself. What if somewhere on this purple wire, somewhere inside the insulation, the wire was broken? Well, then I would not get a circuit, would I? So if I measure continuity from one end of the purple wire to the other, and I get the beep, that's telling me that I have got continuity through that wire. And if I go to the blue one, I can do the same thing. And there I have continuity in that one as well. I don't think you saw that on the camera. Let's just do that again. On the blue wire, I have continuity when I touch both ends of the blue wire. And so that tells me that that wire is continuous. If there was a break inside the insulation of that blue wire that I couldn't see, when I do that measurement, I will get no result. And that means that there is no continuity. Right, that is continuity testing. So let's look at resistance testing then. Well, as I said, resistance testing will be essentially the same thing. We're measuring for a circuit, but this time the meter is going to tell me physically what's the resistance of that circuit. Well, why would I need to know that? Well, let's have a look here. I have a little resistor. And if I, as I just did, pulled this out of my toolbox, and I thought I might use that for something, particularly in an electronic circuit, I probably need to know what the resistance of that resistor is before I use it. Now I can look at the color code, and I'm holding that close to the camera so that you can see the color code. If you can't quite make that out, that is brown, black, yellow, and gold. I should be able to work that out, right? If I've got my resistor color chart, what that resistor is. Let's have a look. Here's one I prepared earlier. We've got a 4-band color code, so I'm going to use 1, 2, 3 columns and the tolerance. My first color band was brown, and brown equals 1. My second digit was black, which is a 0. My third digit was yellow, that's 4. And remember, our third digit is our multiplier, so that's telling me to add 4 zeros. My fourth digit was the gold one. So for our, my third digit is this column here, 10K, or add 4 zeros, or multiply by 10,000, which either way you want to have a look at it. And my fourth digit was the tolerance, which was gold, so that's going to be plus or minus 5%. If I work through that 1, 0 multiplier of 10,000, that would be 10 times 10,000, or I can use 4 zeros for the yellow that does the same thing. Either way, that comes out to 100,000 ohms. So that tells me that this resistor is 100,000 ohms, plus or minus 5%. So it should fall within 5%. 5% of 100,000 ohms would be 5,000, which means that my actual reading should be between 95,000 and 105,000. So 100K plus or minus 5%. And if I wanted to use this in an electronic circuit, it could potentially important for me to know that exact resistor value. So before I go ahead and use that, now that I've worked out what the value is, I'm going to test it. pop our meter here where you can see it, and you'll see that I'm just going to put my meter probes, one on each side. What we're doing is making a circuit through the resistor, and the display should tell us what that resistance is. I've got it on the 200,000 ohm range. 200,000 ohm range. So it will say 200. If it says 200, that means 200,000. And what I can see there, you may not quite be able to see the decimal place, but what I'm getting there is 98.5, or it's flicking between 98.5 and 98.6. That means 98,500 to 98,600. I'm not going to be able to get a more accurate reading than that. But if you think about how much 100 ohms is on a 100,000 ohm resistor, you realize it's probably not that important. So between 98,500 and 98,600, or we could just say 98,500, that's close enough. So that tells me that, in fact, that resistor is 100K, and it falls comfortably within that tolerance range of plus or minus 5%, which would be 95,000 to 100,000. And if I wanted to use that in a circuit and I needed a 100,000 ohm resistor, this would be okay. If I found this resistor and the color code was missing, measuring the resistance across it would again be a very useful tool for me. I would be able to tell what that resistor is without being able to read it. That's it for earth continuity and resistance. If you have a multimeter at home, you can practice this stuff. Continuity is really easy to do, measuring just the resistance across your meter leads like we did before gives you that continuity. You can measure the continuity of any wire in your house. If you're dead keen, you can pop down to Jaycar resistors like this little guy that we used there, worth about 30 cents each. So you could buy a handful of those just to do your own testing if you want to. If you don't have a multimeter, again, if you pop down to Jaycar, you can probably pick up a pretty basic one for $20 or $30 if you're interested in trying this out, or you can wait until the next time we're in the workshop and we'll give it a try. Thanks for watching. Next video will be voltage testing. Don't miss that one. Really important. If you muck up resistance testing, you're going to muck up your resistance test. If you muck up your voltage testing, you might die. So that's fun. See you there.